Hi, everyone. My name is Andrew. I'm part of the cloud capacity team over here at Netflix. Today, we're going to talk about how to spend less money with Amazon Web Service. Oh, there's a title change. Efficient Innovation, High Velocity Cost Management at Netflix. That's internal title. So what to expect from this session? Well, if you've been to a lot of the other Netflix talk, we often talk about innovation and availability in our cloud infrastructure. Well, today we're going to go under the covers and talk about how we manage efficiency, specifically from our cloud capacity management team. We'll talk about how it's changed over Netflix, and more importantly, why, as some of the initial processes that we figured out don't scale anymore at our current size today. And we'll also talk about some of our best practices that we're currently implementing and some of our future goals as well. So before we start this talk, two quick notes. The first is a doctor's note, that a lot of the processes that you're going to hear, please don't try to directly port them over since they're situational and it's dependent on your company. The second one is that none of the processes that we have in place today is because of our close relationship with Amazon Web Services, meaning there's no preferential treatment here. So a lot of them are applicable to companies small and large, one region, multi-region, a couple hundred instances, tens of thousands like we are. So we'll get started. So what's the challenge here at Netflix? Well, for those of you unfamiliar with what we do a lot of online streaming video. Those business metrics relay two major points. First is that we're operating at a very large scale, and we're becoming increasingly global. So there's some business complexities there. Specifically from an engineering perspective, we prioritize innovation and availability above efficiency. So how do you manage costs when it's not the first thing on an engineer's mind when they're deploying a new service? From an organizational perspective, we have a lot of engineers, over 40 different teams, translating to 500 plus microservices, over 90,000 instances, at which about 13,000 auto-scale on a daily basis. So whenever I like to say that sentence, I also like to show this picture, showing our production stack over the course of a month of all the different, split out by our major services. And you can see the auto-scaling going across the top. So a lot of it seems quite complex, and that's the situation. Well, we're going to jump all the way to the solution. Did we achieve efficiency? Well, over time, we did have a lot of growth since the middle of 2010 to the middle of 2015, over 2,000% growth. Now, I'm sure a couple of people in this room who's working at AWS love charts like this, but at Netflix, we care more about whether or not this growth has been efficient. So when we normalize it against an internal metric that we use, streams, the scientific terminology is not 2,000% growth. So over the course of the presentation, we're going to be talking about how we achieve not 2,000% growth. We'll start with the foundations about what you really need to get started from a cloud capacity team and how to start thinking about implementing efficient processes, how they've changed over time to what we're currently doing today, and our future endeavors where we become so efficient that we start generating money, and then we rename ourselves Netflix Web Services. So, another joke. So we'll start with the foundations. The first bullet point is the most important one, where you have to dedicate resources to thinking about cloud capacity management and your general cloud strategy. At Netflix, we have 4 individuals that comprise like a watchtower-like organization, and the terminology we like to use is called undifferentiated heavy lifting. So your average engineer, yes, they can spin up their own instances, they can manage their own capacity, they can set up their own accounts, but that's probably not why you hired them. So instead, centralize all these responsibilities in this one particular team and give them the authority to enact scalable processes. After you create the team, you want to start thinking about the general business strategies and how your cloud strategies support them. And this cloud capacity team can enact policies to match the two while also prioritizing efficiency. What's taking a quick step back here, this is something like we always like to say, some of you may be interested in the cloud, migrating, or operating at our scale. Well, AWS takes care of a lot of those operations for you, but what we encourage is for everyone to think about some of the softer business processes that you have in place that have data center roots. So for Netflix, we don't use a budgeting cycle for our cloud infrastructure team, and we enact a policy called retroactive reserved instance purchasing, which we're going to talk about a little bit more. And really, it's taking away some of the processes that have data center routes that just aren't applicable in the cloud anymore. Lastly, it's important to develop a lot of tooling, so it's very easy to scale up in the cloud. Well, it's also very easy for costs to get out of control. So you have to develop a strong set of tools to relay contextual information back to your engineering teams, back to the engineers themselves about how they've been growing. So we'll start with the first bullet point. At Netflix, who are the capacity planners? Well, we have 4 individuals, 2 from finance and 2 from operations engineering. Our mantra is to serve customers and not keep gates, so making capacity procurement as frictionless as possible. Our main responsibilities fall under 2 major buckets. First is strategy and operations, so we spend a lot of time thinking about scalable growth. We work with a lot of the teams about some of their architectures, especially if they're growing rapidly. We bubble up all this information and we relay it to Amazon Web Services, so both of us are aligned on the long term about some of our goals, and they can also help you as well. As you can imagine, our other set of responsibilities fall under capacity planning, primarily purchasing capacity in an efficient manner. The key word there is planning, not budgeting, with our major teams about service re-architectures or major deployments or holiday growth. And we enact something called retroactive reserved instance purchasing, which we'll talk about over the next couple of slides. And what's interesting is we've been able to efficiently grow at our scale while still not having a budgeting process. So what is retroactive reserved instance purchasing? So for those of you unfamiliar with what a reserved instance is, we primarily use EC2 at Netflix. It's a vast majority of our spend. Inside EC2, there's products called reserved instances where you commit to a duration, 1 to 3 year. And the 2 major benefits are that you get lower pricing and there's some capacity benefits as well. So about every 2 weeks, we look at our entire stack and see what has grown into on-demand, and we'll make educated purchases, and we'll talk about some of the nuances that we have to think about. And we also rebalance unused reserved instances. So another benefit of reserved instances, if you buy it in a particular region, if it's not being used in one AZ, you can move amongst the 3. And within a specific family, you can increase or decrease. So an M3 2XL can become 2 M3 XLs or 4 M3 larges and so forth. So some more nuances that makes reservation purchasing complex at Netflix. Well, we have a lot of auto-scaling. We showed the picture before. So by instance family, by region, we have to know what kind of critical tier services sit on it and how much do we care about capacity for them. And then we make educated purchases. We care a lot about failover capacity. So if you read our tech blog recently or you follow our Simian army, you know that we kill certain regions and we fail over traffic all to another. Well, this kind of growth is unlikely to pick up all the capacity from the on-demand, so we make reserve purchases and we sit them idle until they're needed for a failover exercise. Lastly, we get a lot of false signals. So the major deployment model at Netflix is a red-black. So for those of you unfamiliar, you spin up your new cluster, same size as the old one, and then you shadow traffic, and once it's deemed healthy, you can kill the old one. Well, up to that very last part of killing the old cluster, it looks like a new service. So how do we know whether or not it's a new service or it's just a normal deployment? So to best explain this, we're actually going to use a metaphor that you can find inside our culture deck. They say working at Netflix is like working on a professional sports team. So we're going to use a football metaphor since it's in season, specifically the wide receiver position. So as a wide receiver, when you're doing a play, you need to know 2 major things. First, the route. You need information about the play. And secondly, you make a lot of assumptions about other teammates. So when you're running the play, you're making assumptions about the quarterback, that they're going to throw exactly where he said he was going to throw. Otherwise, you'd be looking backwards, and you're not really performing in the most optimal manner. You're making assumptions about other wide receivers or running backs or tight ends that they're not going to run into your pocket. And so there'll be more defensive people there, and it's a lower probability of you making that catch. So I know it's kind of a far stretch metaphor. We'll bring it back to cloud capacity. Well, as the cloud capacity team, we have to know a lot of information about the play or about our infrastructure and the usage by account, and that helps us give us good information about whether or not we need to purchase. We make a lot of assumptions and create some processes with other engineering teams that, hey, if you guys are going to grow irregularly, let us know. Otherwise, we can assume that this is just a normal red-black or it's just a test. The last bullet really doesn't fit inside the football metaphor. It's more about the control tower. Well, you need to build out strong tooling for your control tower so you can get a lot of contextual information without bothering a lot of the engineering teams every time you see growth. So if you kind of like retroactive reserved instance purchasing and you would like to implement it for yourself or for a company that you're working for, quick selling points in the bottom. The first is you're helping accelerate innovation by lowering deployment friction. So an engineer is more likely to test something new when they don't have to go through a procurement process or they don't need budgetary approval. That also reduces the amount of operational overhead. Lastly, there could be some cost savings, reducing what we call capacity sandbagging. So you're running under budget for a particular quarter, but you know the next quarter is going to be the holiday season and you might go over. Well, you might as well just fill up to your budget every time. Well, only taking what you need could actually create some cost savings when you implement retroactive reserved instance purchasing. So taking all those considerations into mind, we look at on-demand graphs like this for ourselves, and we know exactly what to purchase for and what not to purchase for. So we kind of oversimplified retroactive reserved instance purchasing, so please, I encourage everyone to ask questions at the end of this presentation or office hours, or feel free to reach out to our cloud capacity team, because we're more than happy to talk about this process, and there's a lot more nuances than what we just went through. Switching gears a little bit, talking about your cloud capacity team efficiently implementing processes that match your cloud strategy with your business strategy. And we'll use examples at Netflix. We have a decentralized microservice architecture, so a bunch of engineering teams operating on their own timeline, and we're also operating at massive scale. So how do you combat this from an efficiency perspective? Well, we mentioned before, centralize your cloud capacity team, give them the authority to make decisions or to implement best practices, and it's very scalable because you get a lot of scalability because you're applying it against the organization as a whole. Deployment's almost frictionless at Netflix, and how do you combat this? Make sure growth isn't rapid and out of control. Well, you develop contextual tooling. We'll go over some dashboards that we've been iterating on over time that helps give contextual information about a specific team's growth. We have a very high availability goal for ourselves, 99.99%. How do you combat that from an efficiency perspective, or how do you support that general strategy? Well, we mentioned we purchased dedicated failover capacity. We also like to clump a lot of our critical tier services on more general purpose families or where we have a lot of reservations, so they just have a higher chance of getting the capacity that they need during a failover exercise. So the general point, we're not trying to pick specific bullet points here and say they're applicable for every company, but it's important just to think about your company's strategies and how your cloud capacity team can help support them. So lastly, transparency through tooling. So we mentioned this a couple of times before. The capacity team needs a lot of dashboards, a lot of information to know whether or not they need to make purchases, when to intervene, et cetera. So we primarily use an open source tool that we've created in-house called ICE that helps consume Amazon's billing data, and that's what we use most of our purchases for. Requires a little bit of engineering effort to integrate and to maintain on yourself. You can also go with third-party vendors like Cloudability that already have a pre-existing platform and other customers, and they'll take a fee in return. After you set that tooling up for your capacity team, you want to start relaying that information back to the engineering teams, and we'll go through a couple of dashboards in a minute. In those dashboards, it's also important to choose a business metric to help set growth context that everyone has agreed upon. And this holds engineering teams accountable for their growth, and we'll talk about that through the dashboards as well. So we'll get started. This was our first version of our cloud cost email that we sent back to each auto-scaling group tagged in our organization. At the top and bottom there, you have some cost information. At the middle, you have some business metrics. So we found two things that didn't scale with this kind of dashboard. Number one, we didn't have a good tagging hierarchy, so it was very difficult when services decomposed or got re-architected or someone left the company. It was very difficult to reapply those to the correct groups. Number two, there's back-of-the-envelope calculations that you have to do to figure out your efficiency. In the middle there, you have the business metrics, but afterwards, you have to do calculations versus the bar graphs or the graphs on the top. And we just want to give a visualization, instant piece of information to engineers that they say, hey, I know whether I'm not or whether I'm growing efficiently or not. So that kind of spawned our wave 2 of dashboards. So this is our cost per stream dashboard, still in use today. We send this to the directors and VPs. So we selected a business metric streams. We felt like this was the most variable consideration versus our general cloud footprint. We split out all of our cloud infrastructure costs by major engineering teams, so VPs and directors know how their organizations have been growing over time. Now, the major flaw we found with this one is that most of the people that have the most influence on costs, the first-level engineering managers or the engineering people themselves, they kind of get lost when they see metrics like this. So we knew that we had to make more specific dashboards on the next one. So that's where we're at today, and we'll have some videos playing. So we decided to make 3 levels of dashboards, all kind of similarly constructed, but they give different levels of context at each layer. So this is the highest layer at the VP level. I'll set up the page. On the top left, you have costs, current cost for that time period. On the top right, you have current period growth, and at the bottom, you just have some trend lines. In the middle, you have the major engineering orgs. So it's going to start moving, but we're going to filter by one of our VPs, Yuri, and he'll see instantly what organizations cost the most and what has grown the most. So we'll use a reciting example here about that one cost that hit 99% growth for this quarter, data pipeline. So he now knows that he should engage with that team or ask questions whether or not that growth was reasonable. We mentioned before that we also like to give business metrics. So there is actually a blue line that's supposed to go over the red bars at the bottom, but we had to redact that information. So that's all the amount of context that a VP needs. They just need to know what's the biggest fish to fry, or what's the biggest fish to congratulate, and then how that fish has grown over time or shrunk. So we'll move over to the next set. So this is at the director and first-level engineering manager. So layout's exactly the same, but in the middle, you actually have super service, a new tagging that we created to make maintenance of tagging much more sustainable. So we're going to continue the example from before, look at data pipeline specifically, and you'll see all the super services that fall within data pipeline. And this gives that engineering manager a lot more information about what grew specifically inside his organization after Yuri talks to him about it. So on the right side, you can see there's 2 major super services. Kafka really grew, and then KS actually has no growth. That's just indicating it didn't exist in the prior time period. So you can move it to a monthly time frame. You can see, wow, it's grown 226%. Now in the VP dashboards, this is where we stopped. We said no more context because he doesn't need any more. Well, for engineering managers, we want to provide even more. So we have a separate tab that we're going to transition over. And inside that super service, you can see the specific auto-scaling groups that have grown over time, so they can specifically pinpoint and know which engineers to talk to. So we'll wait for that transition. There we go. So you can see, yes, there's a specific application, KS node. It really has grown over time, so they know to talk with whichever engineer manages that auto-scaling group. So we'll go to the bottom layer now. Same layout once again, but in the middle, you have our super services, and once you filter by a specific super service, you can see the auto-scaling groups underneath, and then the second tab will have even more contextual information for them to make efficiency decisions. So we're going to continue the example and filter by KS. And you can see there's 2. First is KS node, which has grown significantly, and the other one is a brand new service because there's no growth information. So once it moves to a weekly time frame, show a little more information about growth over time. And the general point here is that context needs to be set at every level, but there's no one dashboard that fits all. So we've actually been encouraging a lot of engineering teams to go inside the dashboards that we have and build their own context, save it as their version, and then continuously look at it as they need be. So the second tab here, it has a graph at the bottom that's different from the others. Shows split out by application, by region, by instance type, so just more granular information. So you can kind of see, I've kind of been hinting at it through the dashboards, that Netflix today, we're starting to decentralize more cloud cost responsibilities, which is kind of counterintuitive to what I've said before. But we found out that trying to centrally maintain all of those responsibilities just isn't scalable. And our new ideology is that the people that have the most influence on cost growth should also be the ones that are looking at the growth. On a similar note, we're also engaging on active return on investment analysis with our largest service teams with some of their deployments, since if you just have a positive ROI on all your growth, that means you're scaling. And we'll give a specific example of what the opposite example of what happened earlier this year that could have been prevented with that kind of mindset. And lastly, we're going beyond just the instance level usage. We're looking at resource dimensions like CPU utilization, disk, network, and seeing whether or not, at the very least, whether a service still needs to be on an instance type, and then more information about what we want to do in the future. So the general point here is we want to get to more real-time actionable data, and we'll use a metaphor of driving old car dashboard versus a new car dashboard. So after you're done at reInvent, you're going to drive back from Vegas to San Francisco, and say you start off in an old Civic. The only way you know efficiency is after you deplete your tank and you're at the gas station and you're just doing some back-of-the-envelope calculations. The main issue there is you calculated efficiency after you finished driving, so all your decisions have already been made. So move to the new school dashboards, where at the bare minimum you get a miles per gallon calculator, but what's better is some of the cars have a green or red indicator telling you how efficiently you're driving, or the number of bars that tell you as well. And what's important there is you're getting real-time feedback about your efficiency. And over time, as you start to ingrain it into your behavior, it changes your habits, so you become more efficient as a person or as a driver. So in the cloud world, we want to give more real-time feedback back to our engineers. So over time, they'll actually start becoming more efficient, but they wouldn't realize it off the bat. On a similar note, we want them to start thinking on a return on investment mindset. So we have a very large base of cloud infrastructure usage. Well, a small percentage increase of a large base is still a very large number for us. So people need to be more thoughtful about how they deploy. People need to be more thoughtful about their service architecture. And we're going to use an example of what happened earlier this year. So we have a team at Netflix called the Science and Algorithms team. Mathematicians and statisticians, they sit inside a room and they just beautiful mind all over a chalkboard all day. So they created a new algorithm for your video ranking cluster that ranks your videos left to right in February. And the personalization cluster that did these calculations incorporated that new code immediately. And they picked over 1,400 R34XLs from a particular region. So if you're not familiar with instance sizes, that's quite a bit of R3s. Now, this hurt us in two ways. First, it was their new architecture, so we had to purchase it immediately, so you can imagine how much money that is. And secondly, it also caused availability issues for us, since we have other instance types that are more critical than a pre-compute cluster that were fighting over R3s with them, and we actually had some issues where we just couldn't get the capacity that we needed because we ran out of our own reserved instances. So if they had a return on investment mindset, none of that would have happened. They would have figured out right after they knew they needed 1,400 R34XLs that that kind of deployment would be unacceptable from an efficiency perspective, and they would have had to tune it down. So we're going to continue that example. And this is the flip side. This is the positive story, where our cloud capacity team was able to enact a pretty fancy process to help get us to be more efficient after that deployment. So that specific pre-compute cluster needed to finish all its jobs between midnight and 11 a.m. So that left a pretty large R3 trough during the day. So we looked for another service to fill that trough, and we found encoding. So this is the team that's in charge of transcoding all our raw master media files into the various formats for your Netflix devices. They had short duration jobs, and they were pretty interruptible. So we manually fit them inside the trough in the beginning, and it gave them over 35% more capacity since the spring. So they were so enthusiastic about it, they asked our deployment tools team to, hey, can you guys provide an API for us that shows the unused trough and other instance types in a more automated fashion, since we already mentioned we have a lot of auto-scaling. So they did that, and then they absorbed that telemetry, and they started creating automated borrowing. So we recently posted a tech blog post about this. And this is the kind of opportunities that you can identify by having a very centralized cloud capacity team that sees all the moving pieces together. So more news on this. We'll have some more blog posts as well. Lastly, efficiency scorecard. So this is something we've been working on as well. Another automated dashboard that we'll give back to our engineering teams, telling them, hey, currently, how efficient is your service on this instance type? What's beneficial is that you can also start looking at downstream services after a particular deployment and see whether or not that service has impacted more parts of your infrastructure just than the current instance that they're using. And over time, you can start looking at services together and see what kind of performance characteristic traits that creates. So you can kind of guess what I'm hinting at. For the future of cloud cost management, we're very interested in using containers that are just more efficient than using individual instances by service, by bin packing at the service level. What's not also apparent is that there's also some availability gains when you bin pack at the service level. So we mentioned before, we purchased a lot of failover capacity in specific regions just to make sure there's enough capacity. Well, in a containerized world, you can just boot all your non-critical services and just have all your critical services fill the container. So either from an efficiency perspective, you're buying less reserve capacity for failover, or you have a higher chance of getting the capacity that you need for your critical tier services. Second bullet is more about thinking outside the box. So don't always think about everything from a cloud infrastructure cost perspective. You can also think about it from the demand side. So if you know your business very well, Netflix, more people watch Netflix at night than during the day. And we tend to serve users closer to one of our major regions than further away. So knowing that, US East, when it's at peak, around like 7 or 8 prime time, then people in the EU, they're sleeping. So there's a pretty large unused trough because of auto-scaling. So our traffic team's working on tooling to dynamically shift traffic so all our regions are perfectly balanced. And that makes your regions more efficient as a whole. But that kind of thinking outside the box of just not always thinking about cloud infrastructure cost is also important. Lastly, automated return on investment calculation. So we mentioned we're currently manually engaging with teams. Well, we want to move more to an automated fashion. We have a tool that shows all our A/B tests at any given moment, and it kind of shows the retention gains or subscriber gains from implementing one. Well, right now, they don't show the cloud costs. So you don't know if you deploy it, whether it'll be a gain for the business as a whole. So using information like this from our efficiency scorecards and being able to identify after an A/B or for an A/B test cell or after a deployment what kind of increased costs you have essentially real-time return on investment calculations, and you know whether or not you need to tune down the cloud infrastructure cost to make that a positive. So a fairly short presentation. We talked a lot about how we managed efficiency, and some of them are pretty specific processes, but what was very important is more of the fundamental concept of why we pursued those. In the beginning, during the foundations, it's a lot of heavy manual lifting from your cloud capacity team. Today is a hybrid stage where we have a lot of automation around some cost dashboards, but we still engage with a lot of teams in a manual fashion. In the future, we want to be fully automated and start looking at leveraging products that are just more efficient in nature, like containers, ECS. With this being a AWS event, you have to end with acronyms that are kind of catchy. So we'll start with EC2, everyone contributes cost. So we mentioned before that you want the person that creates the cost to also be the person that watches the cost. And in our Beautiful Mind example, there's people that aren't DevOps engineers that are creating cost as well. So you want to inform them about how your cloud cost has been changing over time and just let other people in the organization know that could indirectly impact cloud infrastructure costs. S3, smart strategy saves. So we spent a lot of time talking about how our cloud capacity team has spent a lot of time thinking about efficient processes, and we showed one specific example of automated borrowing, which is kind of very specific. I'm not going to say any detailed strategies here because it's different by company, but it's just important to think about what your overall cloud strategy is, your business strategy is, and let your cloud capacity team think about how to scale that in an efficient manner. Data transfer, so not really an acronym, but develop transparency. So we talked a lot about how we're creating a lot of tooling and dashboarding to give back to our engineers, and we found out that this is the most scalable way to give context. And lastly, RDS, remove data center sentiment. So not kind of falls in with the second bullet point, but we were just encouraging other people to think about some of the softer business practices that you have. For Netflix, we removed budgeting. We felt like that process just didn't make sense when we were in the cloud, and we've leveraged some other practices like retroactive reserved instance purchasing to make sure that that cloud growth isn't hyperlinear. So on that note, I want to thank everyone for taking time out to listen to Netflix talk about how we do cloud cost management. Contact information in the middle, and right after this talk, we'll have Q&A and also office hours at the Netflix booth. Encourage everyone to complete your evaluations. The speakers and AWS deeply appreciate it. And a couple of plugs for related sessions. So the last one already occurred, but Spot 302 and DD0203 are later this afternoon, semi-related to cloud management. So with that, thank you once again. I'll open up to any questions.